and say, this particular large tier 1 carrier is going to be deploying 40,000 small cells over the next 2 years, and then this one is going to be deploying 30,000, and we're looking at a total of 500,000 small cells. At the end of the day, I think what Mike hit on is critical is what do we define as a small cell? Given the fact that one of the drivers for, I think, small cells is the limited capacity. You've got a modulation rate, a higher order modulation rate on LTE, which dictates that your signal noise ratio has to be higher to maintain that particular modulation rate. And given that, as soon as you're, let's say, a couple hundred yards or 300 to 400 yards away from your cell site, you're going to be dropping off that modulation rate. You're back at 3G all of a sudden. So that's why, to me, it's important to define what are we calling small cells. I think indoor building I like to differentiate between in-building and outdoor. The outdoor, I think, is going to be a longer-term challenge. I don't see a lot of deployment for outdoor small cells. And just to give you an interesting point in that regard, I think we have a different market here in the States. I work at Huawei, and one of the key customers we have is SoftBank in Japan. In Tokyo in particular, it was interesting. I learned from one of our executive marketing folks back at HQ that in the United States, the average number of cell sites per footprint is 1 cell site per 2 kilometers. In Tokyo, it's the opposite. It's 100 cell sites per 1 square kilometer, which just blew me away. But I think what it comes down to is how fast is your market moving in terms of the densification. Everybody knows that Tokyo is super crowded. They've got everybody's riding the rail to work, and so they need this super high capacity. In terms of outdoor, rural carriers, the carrier organization that we have here, I don't see a huge number of small cells being deployed from an outdoor perspective for offloading the macro network anytime soon. Along that line, the CTO of Verizon recently, in the last couple of months, made an announcement that she was going to focus on building out their capacity in their network via their AWS spectrum. And this is the way it's always been done. With the TDMA days, the GSM days, you're going to be looking at adding your capacity in the simplest way. You've already got backhaul of those macro sites. You've already got the tower there, all the primary expenses, the lease of the site itself, and backhaul, the 2 primary drivers in any business case for a small cell. So Verizon made that announcement, and they said we're going to be doing between 200 to 400 cell sites. And everybody asked between 2 to 4, or 20 to 40,000. They said no, it's 200 to 400. And then recently, T-Mobile came out with a similar announcement that they're going to be focusing more on their macro network in terms of offloading capacity, and they won't be deploying small cells in a big way, at least for the next 3 to 4 years. That being said, there's still opportunity for in-building, and that's an equally interesting play there, because you've got Google that's rattling people's cages, and they're talking about coming in the industry in a big way, and everybody knows that Google has very good political clout, very good technology expertise, and they're talking about their fiber deployed campuses and coffee shops and things like that. So there's certainly, I think, a big area for growth on femtocells, and that's where I like to draw the line between a small cell and femtocell. Femtocell, is something that typically I view as being deployed as in-building. As Mike mentioned, stadiums I think is a great venue for that. Coffee shops like Starbucks, the recent announcement there. So there certainly is an opportunity for small cells, and in that particular situation, you're taking advantage of the technical limitations. Let me word it a different way. The technical limitations of LTE play well with that particular situation. So you're getting that modulation rate of 1024 in those coffee shops and in those stadiums. And again, it'll come down to being able to manage the interference mitigation. So those are some of the challenges and the alternatives. I think carrier aggregation from a macro network perspective is going to be huge. There's a lot of things that I think can happen there in terms of offloading the network for capacity. But again, I think in terms of outdoor solutions for small cells, along the line with the announcement made from Verizon, they're going to be focusing on coverage holes and using those. And that was the traditional use of small cells in the past, in the TDMA days, and the 3G, 2G days, is using them more or less for small cells. But again, I do think there's, if one of these tier 1s makes a claim of 40,000 small cells, I'd buy that if they're referring to the indoor or in-building. So.
Thank you. So let's take a minute now. We talked a little bit about some in-building we talked a little bit about kind of the architecture that we're envisioning happening now and into the future. Dean, perhaps you can talk to us a little bit about where we are today with all, you talked specifically small cells, but there's a lot of small cell-like components in the network, and where does that have to go?
Yes, I'm going to grab a slide or two here. In this case, picture's worth 1,000 words. So at ClearSky, we're deploying small cells as a service, working with carriers to create a small cell strategy with the gateways and all the devices. And as a panel, we talked about ahead of time that it would be a really good idea to level set us as an industry and look at kind of where we were at. So in the olden days, which in this industry is like 2 years ago, what we do for indoor coverage is we'd have a macro site or macro network here, and then if we had a residential issue, we might be able to put a repeater in there. The reality is it was mostly cursing and standing out in the front yard for coverage, but it is possible to have put a signal booster in. And even in a small sort of retail location, it's mostly stand outside or churn, but it was possible to use signal boosters. The key thing in the signal boosters, though, is we're pulling capacity off the macro network. As it got more sophisticated, a little bit larger buildings, we get into passive BDAs. So here we've got a bidirectional amplifier, and it's providing signal from here, it's amplifying it, putting it in the building, and then likewise in the other direction. So now you're taking this capacity and moving it inside the building. So as you get into larger with a distributed antenna system, now you still have the BDA providing amplification, taking that signal into the building, and likewise pushing it back out. So this is, Mike pointed out, this is a 5 bars of coverage, but no increase in capacity. So there's plenty of capacity on the macro side, not a bad solution. The problem is that the macro side is starting to load. Now you're bringing additional capacity inside the building, or a need for capacity, but not generating any additional capacity on that sector of that cell. Plus, you don't really know from a network management perspective what's going on inside that building. It's just an amplifier sending in good signal, or it could be sending in bad signal, and likewise in both directions. And then on the very top, for large spaces, the solution's been a distributed antenna system with an RF source. Now you're bringing capacity to it, and then you're connected into the switch. So in a large arena, you'd see these, and these could be multi-operator or multi-tenant. So not just one operator connecting an RF source, but multiple operators connecting an RF source. So that was then. And in our HetNet days now, we have, in a matter of definition, within the femtocell range, about 25 milliwatts in a residential area. And then these devices are really kind of invisible to the RAN. Macro cells disappeared in my diagram. And one of the reasons is that in this technology, the idea of the femtocell is to sit inside the building, self-deploy, look for RF coverage, look at a neighbor list, and set its power levels to a point where it will not interfere with the outside macro network, but provide the in-building coverage necessary. So self-deployed femto for residential. Larger units, up to about 250 milliwatts, are a real good solution for the coffee shop, restaurant kind of market space. And then the next step up are these similar type of enterprise units in a grid arrangement that they can speak to each other and do handoffs within themselves before they backhaul up into the switching network. And then as you get larger, you can have local controllers that manage some of that handoff and switching and make it more intelligent. You can then backhaul that. The common denominator here is using cheap backhaul. As you get into bigger buildings, you might want to look at some dedicated backhaul. But normally, this is public internet using the homeowners with the business owners backhaul. And then the solution for large is still the DAS. So in the HetNet world, we've developed a whole new family of products in this middle space, still relying on our good old DAS systems with multiple RF sources for the largest facilities. Now, last point on this is that these can be multi-mode as well. Today they're normally 3G, but we're starting to see the multi-mode LTE devices. So those, by this time next year, it'll be quite common to have both the 3G and an LTE femto in any of these deployments. So, back to that.
So, all right, so now we've talked a little bit too about network evolution then and now. I think it's a real appropriate time to bring Rob into the conversation. He's had the experience of deploying it, not just from some of these topics that we talked about, but there's some other considerations and realities that he'd like to share. And it's a great opportunity to take advantage of the lessons learned here.
As the only carrier on the panel here, I figured I might as well give you a little perspective of background as to why we got into it and where we're going with it. And I hate sitting down because I've been sitting down all day, so you got me standing. By the way, the good news is I don't have any slides for you today. If I did, I'd have 45 and I only have 5 minutes, so you know, we got to do it. But let me give you a little background. Why do we get into it? Why are we interested in the HetNet concept in the first place? Well, now think about this. Back in the 1960s, one cell was all that was necessary to cover the city of Chicago. Of course, only 12 people could make a phone call, but one cell did it. You know, if you're one of the lucky 12, you got a chance to get through. Same thing with Manhattan, by the way. Well, we decided we needed something a little better, so we built cellular. And when Jim Leno came on board, we had 2 cell sites that he put up for us. That covered all of Brown County. Now, we were happy as lark. Everybody in Brown County had great service. So I turned to Jim yesterday and said, Jim, why do we have 50 cell sites in Brown County? This doesn't make any sense. We did it with 2. Come on, I was the engineer at that time. It takes you 50 to do what I did, you know, back in my day. Well, obviously there's another side to that story, and that is that, needless to say, we have a few more customers, and they use it a whole lot more. So, what are we going to do? Does that mean that in another 10 years we should have, 650 of those monster cell sites out there? Well, obviously not going to work. And besides, we've solved that problem. We know that we're rolling on LTE, and LTE is a salvation for everything. Why would we need HetNet? Well, practicality of it is that we discovered as a carrier, we rolled out LTE. And we found this dirty little secret. You see, when our customers can surf faster, they surf a whole lot more. And this is not our dirty little secret. Everybody that's been in the industry's found that. Now, this one little secret I'm going to give you that you may not know and may not have heard is that once people get used to 4G, they surf more regardless of what network they're on. And so we're finding our 3G is, the doors are getting blown off. Why? Because they've been doing it in 4G. They want to keep doing it as much in 3G. And they expect that capacity. So, what did we as a carrier have to do when it came to that? Well, we hadn't rolled out our small cell yet. We were still in the process of doing it. So I went over and knocked on our friendly vendor and said we would like to have you please come in and give us another RNC. We love to spend millions of dollars with you, so please give us another one of these boxes in here and we'll throw that at it, because we like spending money. It's something that I live for as one of the owners of the company. If you believe that, I got a bridge in Brooklyn I've really been trying to get rid of, but we did. And then when we got to our own building and we're at our own corporate headquarters, or our cellular headquarters, we discovered something. We had a lot of people turning their phones on in there. We have a lot of employees. And then we have people coming in and testing their phones and otherwise. We had to have good service. So we went to Jim and said, hey Jim, we got a problem here. We don't have enough bandwidth. We don't have enough signal here. So what did Jim do? He put another cell site in. Well, actually just a sector, but he put another sector in there, loading up our network. We're not talking about a $2,000 addition, $40,000, $50,000 to try and get more capacity in our network. If we had had our small cell solution in place at the time, 1, we wouldn't have spent the money on the RNC, and 2, we wouldn't have had to pay for and use up another channel and tie up. We could have put in an enterprise Femtocell in the thousands, $6,000 or less, and served that entire building. We would have had 29 channels worth of voice, 32 channels worth of data, And if that wasn't enough, we could put another one on the next floor and cover people with that. Or you put another one on the third floor and cover them with that, or we could cover them all with the one cell. So for the, $1,500, maybe $20,000 or $15,000, maybe $20,000, we could have more capacity we could possibly get off of a macro cell. Well, that's what we could have done if we had it. So we started to look at it and said, how are we going to do this? Well, the other thing we saw in here was, why are people interested in small cells? Now, we don't have a churn problem. I'm happy to report, we really don't. We were very, very low on our churn, maybe the lowest in the industry. We're proud of it. But that isn't always the case for people. And one of the reasons that people have churn is coverage. They can't get the service where they want it. I want to be at my house, I don't have service. Sat on a plane a few months back, sitting next to a guy who had AT&T. And since AT&T is not here, I can tell the story. I said, what do you, he said, well, it's the only one that had the iPhone, so I got it. Oh, okay, great. What do you think of it? Oh, terrible, I can't use it. There's no signal. I mean, it's absolutely atrocious. I said, well, have you ever heard of this thing called small cells? I have. I've got a macrocellular, whatever they call it. I've got this wonderful thing from AT&T. I put it in my house, and I've got 5 bars of service. It works like a charm. I love it. And I said, well, now that Verizon and they weren't my territory, so I couldn't say us, but Verizon and Sprint have the iPhone, you could move on. Oh, no, I can't. So why? Because I got this box in my house, and I got great service in my house. And I said, well, Verizon and Sprint will sell that same kind of box. Oh, no, I've got my AT&T box. I'm going to stay. So what's your service throughout the country? Oh, it really stinks. But I get great service in my house, and I run my business from my house. That kind of said, okay, maybe churn might be a good thing. As a matter of fact, somebody had a speaker, and I can't quote where it was from, so you'll have to take it as anecdotal. They said that they, when they were experiencing churn, they would take a customer that was ready to churn, and they put them on a small cell device. 96% of them kept the service. These were people who were going to churn, stayed on the churn. Now, it wasn't Sprint that I'm talking about, but I can also say that Sprint has put in a bucket full of these things, and they wouldn't do it if they didn't need it. So we're excited about the small cell. We're rolling it out. What have we had? Well, we've only had it out for 3 months. We rolled it out in May, and we didn't advertise it. We simply would tell our people that we now have these, and if people have problems, they can put them in. We put in 50 the first month. The next month, we didn't advertise it. We didn't put it on our webpage, didn't do anything exciting about it. We had 100. The following month, again, now we're still thinking maybe we should advertise, maybe we should put it on our webpage, maybe we do something. We sold 150. So we have now 300 in 3 months, and we've not advertised it once. Now we put it on our website, and we put on it also what our customers think about it. And the customers are telling us that they absolutely love it. Where they did not have quality service in their house, even though we had 50 cell sites in Brown County, they happen to be in the guy that built in the middle of the hole that Jim hasn't figured out how to cover yet. Put a Femtocell in there, they've got 5 bars of service, and they've got 3 megabits of data. Think about it, they're the only ones using that. There's nobody else sharing that CDMA signal in the house. So we've had very good luck with that. We're getting ready to roll out the enterprise version of the product, which we can put into the businesses. And one of the things to think about there is that if I put it into one of the manufacturers in town, I've got an engineering company, they built on top of the highest hill in town. You'd think that would be a perfect place to go for cellular. Well, actually, it was not quite the top of the hill. What they did is they built it in the crevice on the top. I think it was a volcano one time. So they've got the worst signal in the entire city. If you want to use a Verizon phone, you go out the front door and you get 1 bar of service, you can make a call. If you want to use the US Cellular, it's the back door. AT&T, well, and ours, we're about the same. Putting a small cell enterprise in that building, they've got 5 bars of the service. Think about the guy that's in the cubicle next to the guy with the Cellcom phone that's on AT&T, and he sees the guy making the call in the building. Unless he's a smoker and needs an excuse to get out of the building, he probably wants to move over to Cellcom. So we're kind of excited about that. We're so excited about it, we've actually rolled out a wholesale product. What we're going to be doing is offering it to all the small carriers, as is our friends over here at ClearSky. We can't all afford to reinvent the wheel every time. Here's the situation you've got. Sprint only has 1 building, or actually I think 3, that they offer all their small cells. Those are their homing points. Verizon, again, same thing. Same thing with AT&T. They don't have a lot of locations for them, but they have it on there. So what ClearSky is doing for the GSM side, we're doing for the CDMA side, we're going to be building a platform that everybody can work on. We've got to work together, and that's what we're doing with it. So are we excited? Has it worked well for us? Yes. Have we had any real churn off of it? A little bit. We've had in the first month. Some of the customers didn't realize it takes a little while to turn it on. It needs, in our case, GSM signal. Guy couldn't figure out why it took 2 hours for the unit to come up. I said, did you plug in the GSM receiver and stick it outside the door so they could see the satellites? He said, no. I said, that's why it took you 2 hours. Move it outside. It would have been a whole lot closer to 45 minutes, but it does take time to set up. Other than that, we've had no issues. It's send it out to the customer, they install it themselves, they plug it in, it works, and then we got a happy customer.
I know you just sat down, Rob, but I wanted to actually ask you a question that came up in our prep calls. What about the back office, and what about the distribution? What were some of the issues around that, and how did you integrate them into the business?
Well, we looked at, if I'm understanding your question correctly, is that it's not as simple as simply going out and buying a little box and sticking out there.
Right.
You're actually putting in your own MSC. It's a second switch. It's like we have one MSC, now we've got a second one, and that is our cellular one. What we have in our case is we've, for our hosted solution, we put a gateway out at each of the carriers that are out there that are will be on our hosted network. And then we have the brain sitting in Green Bay. So all of the traffic stays locally, all of the data traffic stays locally, but the signaling comes back to us and the operational measurements come back to us. So you need to have that in there. In that, you're also talking about 911. You've got to make sure that your calls can handle a 911 issue that gets sent to the right place. You can actually locate it in the building, because quite frankly, the small cell is a different animal, and so you've got to make sure that you can nail it down. You also have to do CLIA compliance, and again, you need to have all the infrastructure deal with CLIA so they can get in there and look at the calls that are going through with it. You do have locking down the network as far as if it's a roamer, how are you going to get them on? How are you going to authenticate them? They authenticate a little differently, and you have to go through and make sure they authenticate on your network. All of these are some of the details that go into place. We basically have the major cost element of our network is at our core. The stuff that's out at the local sites is actually quite reasonable.
Thank you for elaborating on that. All right, so maybe one more point, and then we can see these questions. But so we talked a little bit about kind of what we're doing today and what we're seeing in short term to maybe next 6 to 9 months on the roadmap. Mike, maybe you can share with us kind of what are some other features or capabilities that we need to keep in mind or that are coming that will also help with the management of these networks?
So I think I'm always humbled by the amount of work that we have to do in the short term to light up these very new types of networks. So residential, enterprise, and even metro cells, maybe different, outdoor metro cells, different perspectives on that. But humbled because it's a lot of work to do. So it's sometimes it's hard to lift your eyes up and say, what's next? What's on the long-term horizon that we need to be working on? My view is that that infrastructure will get us so far, but we actually have to then go back to the typical playbook we always go back to when it learned in IP networks, which is how to do proper load balancing across those networks. So today we do sort of single standard load balancing in the context of, or like using caching. We talk about video caching, and we'll talk about content delivery as a method to do time-based load balancing across the network. I think the opportunity in the future is going to be what's sometimes called as multi-RAC, multi-radio access technology control in the industry, which is saying, look, in this building you may have 3G, 4G, Wi-Fi, DAS, small cells, and macro. Maybe not macro inside, but maybe all as a method to access a subscriber. And those will all have varying levels of congestion or utilization, and in fact actually all offer different properties. And I forget if I use Wi-Fi. And I think the really intelligent next step is going to be load balancing across those layers, and actually moving applications and moving content around. I think that is going to drive a pretty tremendous need in the terms of real-time data analysis, real-time data and congestion awareness, as well as understanding subscriber policies and moving congestion or moving traffic around to the appropriate distribution channel to get into the subscriber to meet their SLAs. But I think that's the next step that we're going to be having to look at in order to tap into available capacity inside the network. But fortunately, we've got enough tools in the toolbox to keep us busy for the next couple of years, I would say. So we'll see how that one emerges out on the standards in the future.
And then perhaps Steve, what about from your perspective, from a hosted environment, does that change any, or does it become easier, more difficult? How does that work?
Well, not to repeat Mike, because I agree with everything you said, but they're a little bit more near term as Wi-Fi. It doesn't make sense for residential, because residential we're using their by definition we're using their backhaul to light up our Femtocell, so they've obviously got Wi-Fi in that building. But Wi-Fi is not created equal. You start getting into a larger office building, and you've all seen it. You get out your phone, you'll see about 15 different closed Wi-Fi networks, all useless to you as an individual, but useless to you as a carrier also if you're off them. So the future is the Wi-Fi hotspot 2.0 with network-based authentication, and that integrated inside the building can overlay a building at the same time the 3G or LTE signals overlay the building. And now you have centralized authentication, and your customers and other authenticated customers that might be roaming in can actually roam into your managed Wi-Fi networks. So Wi-Fi has always been kind of the quick, simple thing that any homeowner can do, but with this new level of sophistication, we can really add it to our entire network plan and do some really exciting things from an overall management perspective. So as we get into these larger buildings, Wi-Fi is going to be a really valuable tool.
And I'll perhaps let you close and then open it up for questions. You've talked a lot about in-building and the enterprise, and so perhaps some final thoughts on how that might create an opportunity for the carriers.
So I've also spent some time talking to some of the tier threes, and that's where they've expressed interest as well at this point. Is the in-building hospitals, schools, and given the fact that they also have the connections, I think the commercial aspects come into play there as well too. Parking garages, things like that. All these are places where I think are the earlier opportunities for some of the tier threes to look at. Given the relationships they're going to have at the city level, it's going to give them an easier opportunity to get right away in those locations. So those are some of the areas I think worthwhile pursuing, particularly with the fact that this panel as a whole I think is focusing on these in-building opportunities in their term area to focus on. So.
And if I can add to that, where you're at right now isn't a land grab. Think of the Sooner State. We're there right now. If you look at what AT&T and T-Mobile and Verizon, Sprint have all done, they've worked to even get whether they're getting a Wi-Fi or they're getting something else in there. They want to get a land grab. They want to own it. The airports, they want to own the coffee shops. They want to own any place that anybody's doing something Wi-Fi-wise. Or if they aren't, if they can get in the case of the ones that are more aggressive on the Femtocell, they're putting in the small cell. We think that this is an opportune time for each of us to get into that land grab. If you put in a 3G today, and the beauty of CDMA is you put in a 3G CDMA, it's the same kind of platform you can use for your LTE. Just plug it in. You can move easily to LTE because it's an IP base on it. But the beauty that we're looking at is we want to get in and control that land grab. I mentioned, I don't know if I mentioned Oshkosh today or not. University of Wisconsin Oshkosh, we went down and visited them. They're interested in us putting in their a solution. We can put in 7 Femtocells, cover the entire campus, and give them great service for that. They came back and were really proud of themselves that they have Wi-Fi across the campus. And we said, well, great, how many hotspots do you have? This is not a big campus. I can cover it with 7 small Femtocells, okay? They told us they have 800. I said, who did your engineering? My vendor, Cisco. Okay, I know who won that battle. We went over to Stevens Point, about the same size campus. We walked in, we said, we're looking at putting in Femtocells. They're very interested. Matter of fact, they want to beat Oshkosh. They think it's a great idea. They'd like to move forward with it. We said, well, you know, we understand that Oshkosh has 800 femtocells. Hotspots. Do you believe that? Said, yeah, we got 1,400. Who's your vendor? HP. Okay. So the reality of this is that Wi-Fi is pretty badly screwed up today. So if you're going to go in and you're going to put in some small cells, why not also look at coming in and offering to offer a managed Wi-Fi service for them at the same time? Now you've got the best of both worlds, because now your customers can use it where they may not have been able to otherwise. Now they're not going to be interfering with themselves all over the place because it's a managed type network. So just something to keep in mind is this is the land grab, so that when 4G comes, you're ready for it. And by the way, I got to tell you, I did go over to Korea. I did get a chance to see 4G. Walked into a Starbucks in the front of the room. I got, what was it? I had 19 meg up and 30 meg down. I thought, this is insane. The guy said, walk in the back. I walked in the back where there was not interference to the outside. I had 60 meg down and 30 meg up. Now it was a 20 by 20 system, about 60 megabits. They weren't using the Wi-Fi in the building. They were using LTE.
All right, thank you. Now's your chance to ask questions. So, who would like to start? Nobody has a question?
How did you handle interference in a small cell solution? Even though it's low powered, you know what we found, because we have a small cell solution, we found that it works great where there's a certain level, level. If it's coverage and we're trying to increase capacity, we were having problems with it ping-ponging between the macro and the femto. We're working with our vendor to look at trying to cluster it to try to make the femto more predominant. But how did you guys handle your interference problem?
Really easy. Just become CDMA carrier. No, we actually, I'm going to answer, and I think you're more of a GSM question, but we, in CDMA, Sprint has been able to roll it out on code channel because of the soft handoff, and they've been successful. They've already done the balances necessary. My engineering team is a little more conservative and cautious. We are going to go on the same channel for our, because we have different channels, we're going to use the same channel for our data, but we'll be using 2 different channels for our voice, at least initially. But no, GSM is.
So, if I can answer, in the GSM context, it is an interesting evolution that's happened in the industry. I think we've learned a lot about how to do this and do it well. So I have many examples of the 3G femto technology where we've taken exactly that architecture, which is called an IUH-based standard, and we have pushed that into the outdoor environment, living on shared carrier underneath a multi-vendor macro, where we have actually now that I've just reviewed the KPIs this morning, and they are basically the same as the macro. So the technologies that are now starting to become available, and you don't get this with these standard IUH interfaces, you need, there's some I wouldn't say proprietary, but there's some extra special sauce you have to throw in there, which actually is mobility related special sauce. You start getting into power adaptive control, and you start getting into understanding the carrier management strategies and when you offload and what your camping strategies are with these things. You understand a lot of the timers for how to when and how to handle the mobility events. So in fact, actually all of these are very solvable problems, and I think what I just said was one of the most challenging. It's a busy street with cars moving in and out and shared carrier underneath the macro. I think we've got that pretty much nailed. So if you need some help, let us know. Maybe we can help guide you towards the right questions to ask.
And it's cheaper than moving to CDMA.
Any other questions? Well, while you're thinking of your next question, I'll just give you a little bit of logistics announcements. First of all, you have received evaluation forms when you came into the room, and the events committee, and I am actually a member of the events committee, we really welcome and encourage that feedback. It's we do sit and we read through all the feedback and we use it to help plan subsequent conference sessions. So please, we thank you in advance for providing that feedback. So if you can give that to us, we would greatly appreciate it. And then the second announcement, which is one probably if any of you are a little sleepy might appreciate, coffee and snacks will be right outside in the foyer when we're done. But you're not off the hook yet. Any more questions for our panelists? Thank you.
Okay, so you talked, from what I understand, most of the competition is toward indoor small cells and that kind of thing. Really, what are the different design considerations for an outdoor small cell versus an outdoor cell? What is the difference in strategy going in, a small area? Are there certain like profiles that seem appropriate for
I can give you a couple of examples. Sprint rolled one out.
You want to repeat
Oh, I'm
the
sorry,
question?
repeat the question, thank you. The question is there, what is the profile, what do you look at when doing, because we've been talking about internal, or small cells, in building. If you're doing an out of the building, what sort of things do you look at? Is there certain profiles, why you put it in, what do you do, how do you distinguish that from putting in a macro cell? Is that pretty okay? We're looking at, there is some outdoor cell sites that we can use. I'll first touch on what Sprint did in just north of Kansas City in a small community. They had a town they couldn't reach, they weren't doing very well with it. They had a choice. They could put a macro in at the cost of a macro cell, and with the tower and everything else that was involved, 150 plus to do. They decided instead to put in 3 outdoor based enterprise type femtocells or picocells. They're able to cover a 5-mile area, 5 square miles of college or community with those 3 cells. All in, after the installation costs and everything else of doing it, $30,000 roughly. Paid for it in 3 months, and it had the ability to deal with it. But in that case, it was a closed community. I mean, somewhat closed. It was an area that didn't have service. They did have to deal with if there was any, they did have to put it into the scheme of looking at optimization, because it was part of the macro network. But obviously at a fraction of the cost and very successful. There is today a problem that cells, small cells today, or femtocells, are designed for handing out, but not handing in. Active hand out, not active hand in. They do passive, but they don't do active. The platform we have will later, in 2014, we will do both, which then makes it so that any place I've got a little spot, we've got a place that we drive over a hill, and for some reason we drop calls and we can't afford to put a whole cell site in there. We can put in a small site, cover a couple mile radius off of that, and hand in, hand out, and we would be in great shape for it. That's the kind of places we're looking at it. The other place we're looking at it is Lambeau Field is an example, and this was more of an in-building. We were talking, Patrick mentioned that earlier, but you take a place like Lambeau Field, I can't tell you what it's going to cost us to put a DAS system in there because we're under NDA there, but we could probably buy a cellular switch for it. Give you an idea. What we have discovered is that it's about $1 per square foot is what a DAS runs. And so if you're trying to cover an area, whereas with a small cell you can probably do it for 20 cents or less, more in the pennies area. And so economically, that's it. So I look at it as county fairs, movable fairs, where you would have put a cow before, you can put in a couple of small cells. All your biggest problem you've got is backhaul. If you're putting 3 meg out there, which is what you're doing at that location, you need to get some backhaul. So you either need to do, and we're using unlicensed spectrum for that. We've got a location that we're also putting in is a University of Wisconsin Stevens Point has a environmental camp up in the North Woods. Nothing is there. It's funny, they have roads there. I'm not sure that they have anything else. But they do have a very nice campus. And they have absolutely no Wi-Fi, and they have no cellular service there. We're going to be putting in a enterprise femtocell to cover the entire campus. And all we need is some unlicensed spectrum, microwave we're going to shoot in there. off of one of our towers a few miles away, and now we bang that service and no one else does. Those are the places, but we're doing it.
Yeah, so a couple of just quick rules of thumb that we found is that, as Rob pointed out, there are kind of two use cases in the rural markets. One is the remote village, just as Rob talked about. So that makes a lot of sense. You don't have to worry about RF plan. You just got a place to cover. And we're seeing success with via satellite uplink and downlink to remote locations like that. Very cost effective and great performance. And then once you move into more populated areas where you do have some macro coverage, the big difference on small cells is you really do need to involve your RF lines. So indoors, enough intelligence in the femtos that they'll run through this power management schemes, and in most cases, notwithstanding the gentleman's question, in most cases where there's poor coverage in the building, you're not going to have macrocellular interferences, just quick deployment. But once you go outdoors, you got to pay attention to your macro, so you got to get the RF guys and do some tuning, get them involved.
I want to add one point to what you said. So you asked what were some of the key considerations. I think the in-building penetration loss is one of the key aspects of it. I mean, you hit the nail on the head here. The fact that, you know, if you're a home, you're looking at 8 to 10 dB loss. If you're a building, you're up to 18 dB loss or more. That in itself allows a small cell to play where a macro cell couldn't have, because of the fact you've got controlled isolation there from the interference from that macro cell network. So that's one of the key points, and that's why I think it makes it easier to not have our RF engineering guys working on the in-building deployment versus on the outdoor. You're going to have RF guys that need to worry about the fact that you're going to be interfering with the macro cell. You don't have that protective, barrier that's your home, but that's your building. So.
Yeah, and if you don't mind me just
No, go.
punctuating a point, I would say that the experiences that we've learned on the indoors, you can't ignore the RF plan. It's a little bit easier, but you still have some pretty interesting challenges like stairways and stairwells where you have discontinuous, loss pattern. So we found that actually if you want mobility, especially in high value mobility, which is often the case in enterprise, you have to pay attention to those. In the outdoor, actually, we reduced this to, I'll call it a set of RF design guidelines. I mean, we still have to respect Maxwell's equations. They didn't somehow disappear. So we have an exclusion zone depending on the type of service that's being offered. So for example, data is actually a smaller exclusion zone than its voice and data. Actually, because the PS is much more tolerant if you have a hard handoff or a drop. IP actually doesn't care. TCP was designed for packet loss. So it's not, that you have a resend, it's not a big deal, and you have session continuity. But if you stay true to the RF design guidelines, actually then outside of those design guidelines, it's a full circle, and you can start dropping them pretty much forever, because the interference management schema that is available now for heterogeneous networks, especially with LTE, but also with IUH and 3G based environment, actually does allow you to do this in an easier way. It's not as absolutely strict. If you're going to go in the exclusion zone, then I would forget it. You just turn down your macro. If you really need capacity there, that's when you turn down the macro and you say, I'm going to add in or reduce one of the carriers and then drop in a tremendous number of small cell layers in that area. We do that a lot in venues. Bring down a carrier and then drop in, 100 or so small cells. So like, for example, just lit up in Singapore, the Formula 1 race that starts in a couple of days, and that's one of the features.
To that point, I want to mention that when we put in a repeater, which we won't be doing in the future, but we have in the past, we look at the RF and that is built anyhow. So I'm not going to put an enterprise in without having an RF engineer look at it.
I also think that's one of the differences between Wi-Fi and LTE. The advantage that LTE is going to have in the future is it has the ability to allow an RF engineer to make sure that there's not interference. So if we're looking, let's assume a large enterprise building, and you've got multiple small cells in there. You have the ability to now control the interference between those small cells versus a home unit is only going to have one unit probably in that home. Wi-Fi doesn't give you that flexibility. So, one of the big advantages moving forward is that LTE will give that advantage to be able to control the RF interference between various small cells next to each other in an enterprise environment.
One last question? All right, well, thank you very much.